All right, so today we're going to talk about exponential functions, and let's go ahead and talk about the parent function. So the parent function is f of x equals b to the x power. That's what the parent function is. So now x is going to be in the exponent for all of these. And there's two types of them. You got an exponential growth, and that's if b is bigger than 1. So if b is bigger than 1, that means that you have an exponential growth equation. Okay, and it's always increasing from left to right. Okay. If b is less than 1, that means it's an exponential decay. And is always decreasing from left to right. Okay? An asymptote is a line that the graph gets close to but never crosses. It actually never touches or crosses. Okay? So it's going to get very, very close to it, but it's not going to physically touch or cross the line. So let's go ahead and continue on and do some examples. And the best way to do these, honestly, is by making yourself an XY table. Okay? So let's go and make an XY table. Okay, and the points you're going to choose typically are going to be like -2, -1, 0, 1, and 2. Well, if I choose -2, that means it's going to be 3 to the -2. Now, we learned last unit that that's really saying that it's 1 over 3 squared, or 1/9. So at -2, it's going to be 1/9. And it's going to be about right there, give or take. Okay? At -1, that means it's 3 to the -1, which is the same as 1 over 3 to the first, or 1/3. You're going to estimate most of these. Okay, at 0, it means it's 3 to the 0, and anything to the 0 power is just 1. And then you got 3 to the first, which gives you 3. And then 3 squared, which gives you 9. So you can see these rapidly grow really, really quick. Now, I want you to take a moment to think about it. If I gave you, let's say, an x of -100, that means you're doing 1 over 3 to the 100th, right? Well, that's just going to be 1 over a really, really long number. None of that is ever going to get to 0. So for all of these parent functions, all these functions, your asymptote is going to be the line y equals 0, because your y's will actually never get to 0. They're going to get close to it, but they're not going to physically touch across. Now, from the naked eye, it looks like it's going to touch it, but it actually isn't. Okay? And the y-intercept, very easy. When y is 0, when x is 0, y is 1. Or 0, 1. It's your y-intercept for most parent functions. Okay. Domain. This, because of this, and because of this, this is going to continue on. That means that the domain is going to be from -infinity to infinity. It's going to go left to right the same. It's going to be -infinity to infinity. And for most of these, that is going to be the case. The range, though, the range starts at actually 0 and goes to infinity. But notice, because we don't touch across, I had to put a parenthesis around 0, because it's going to get very, very close to 0, but it's not going to get to 0. Now, as x is going this way, y is going this way towards positive infinity. As x is going to the negatives, though, it's getting very, very close and approaching the number 0. Okay, and that's what that asymptote does. It changes your end behavior for these graphs. All right, let's take a look at another one. And let's look at 1/2. So again, make yourself an XY chart. Again, do -2, -1, 0, 1, and 2. So according to this, it's going to be 1/2 to the -2. Now, when you do that, and I'm going to do it down below here so we save some space. I do 1/2 to the -2. That's the same as saying 1 over 1/2 squared. Well, 1/2 squared is 1 over 1/4, and we're dividing two fractions. Well, when you divide two fractions, you do keep, change, flip. So actually, it's going to come out as the number +4. So -2, 4. Same thing for 1/2 to the -1st. If I do 1/2 to the -1st, that's the same as 1 over 1/2. Well, if you do that, that's 1 divided by 1/2, which is the same as keep, change, flip, which comes out as 2. And this is why the graph of these is decaying from left to right. When you do 1/2 to the 0 power, again, anything to the 0 power is always the number 1. And then 1/2 to the 1st is just 1/2. And 1/2 squared, where you square the top and the bottom, would be 1 over 4. So same idea, but this time, notice it's decreasing, and again, same thing that's going to happen. The asymptote for this is going to be y equals 0. It's going to get very, very close to that 0 mark. And you can see in my graph, it looks like it's going to touch, but it actually isn't if you were to zoom in with an actual graphing calculator. Our y-intercept is still 0, 1. Okay, the domain, still negative infinity to infinity. We are still going left to right from negative infinity to infinity. Our range is still from 0 to infinity. It's still going from the asymptote to infinity. The end behavior, though, this time as x is getting bigger this way, it's the one that is approaching the number 0. As x is getting smaller this way, that's when it's going up to positive infinity. And the same thing when you have something like 2/3. So x, y, again, -2, -1, 0, 1, and 2. Okay. And so same thing if I do 2/3, the -2, and again, I'm going to do the same thing I did last time. So 2/3, the -2 is the same as 1 over 2/3 squared. You square the top and bottom, so it's 1 over 4 over 9. So when you do that, that's really 1 divided by 4 over 9. Well, you can't divide two fractions. You have to keep, change, flip, which comes out as 9 over 4, which is about 2.5. Okay, same thing for 2/3 to the -1. Same thing. If I do 2/3 to the -1, it's the same as 1 over 2/3, which is 1 divided by 2 over 3. Again, keep, change, flip. 1 times 3 over 2. So you get 3 over 2, or 1.5. Anything again to the 0 power is always 1. 2/3 to the 1st, just 2/3. And 2/3 squared would be 4/9, which is a little less than half. You can see there you go again. It's a little bit wider one. Same idea. I get very, very close to 0. The asymptote is y equals 0. Y-intercept still hasn't changed. It only is going to change your transformation. So we're going to talk about on the next slide. Okay, domain is still going -infinity to infinity. Range is still starting at the point 0 and getting up to infinity. Again, as I'm going this way, I'm approaching the asymptote of 0. As I'm going this way, I'm approaching positive infinity. So let's talk about transformations. Oh, we got one more. Sorry. Lots of examples of this. So again, say I'm saying x comma y. So you got -2, -1, 0, 1, and 2. So 5 over 2 to the -2. So you got 5 over 2 to the negative 2 is the same as 1 over 5 over 2 squared, which is 1 over 25 over 4 because you square the top and bottom. So 1 divided by 25 over 4 is the same as 1 times 4 over 25. Gives you 4 over 25, which is a roughly, give or take, 1.16. So negative 2.16, somewhere around there. Then you got negative 1. And that's going to give you, when you did it, you would get 2 over 5. And 2 over 5 is the same as 0.4. Anything again to the 0 power is 1. And you got 5 over 2 to the first, which is 5 over 2, or 2.5. And then 5 over 2 squared would be 25 over 4. Which is 6.25. Which is about right there. And it's going to look something like there. And again, same thing. You get very, very close to 0. You don't touch it. That's my asymptote. My y-intercept is here. 0, 1. The domain, negative infinity to infinity. So you can see the domain doesn't really change. The range, it will change when we do shifts and transformations. This one, x is going this way, y is going up to a positive infinity. As x goes this way, you're approaching the asymptote of 0. All right, transformations. And notice here, if you look at our rule, it's the same rule we've been dealing with. The only difference is h is now in the exponent. So again, h is still your horizontal shift. Okay, positive is going to shift it to the left. Negative is going to shift it to the right. Okay, because that means that h is really positive. Same idea. When I say negative or positive, I'm looking at this symbol right here. Positive there would be left, negative would be right. K is your vertical. Positive is going to still shift it up. K is still negative is still going to shift it down. Okay. Again, when A is negative, it's going to reflect over the x-axis. If A is bigger than 1, it's a vertical stretch. If A is less than 1, it's a vertical compression. Same rules that we've been dealing with this entire time for every single transformation. All right, they want me to identify the transformation here. Okay, so first, and the parent function. So first, my parent function, let's start there. Is f of x equal to 4 over 3 to the x. So these parent functions could have different numbers for b. Okay, so there you go. So when you're looking at the transformation, that negative in the front, you got this negative here. It's going to reflect it over the x-axis. Okay. You have a positive 2 there. That means it's going to go left 2 units. And you have a positive 7 here, which means it's going to go up 7 units. Okay. Number 4, let's start with our parent function. It's f of x is equal to 5 to the x. Okay. You have an a value in here, the 1/2. A is going to be a vertical compression. And it's a vertical compression. Your negative 4 up here is going to actually shift it right 4 units. And the negative 2 back here is going to shift it down 2. All right. So let's talk about graphing when you have a transformation. Okay. The first thing I would do is I would figure out what my actual xy's of my parent function is. Just 3 to the x. So negative 2 is going to be 1/9. Negative 1 would be 1/3. 0 would be 1. Okay. And then 1 would be 3, and 2 would be 9. So that is just of that function right there. Then this plus 1 says that everything's going to move up 1 unit. Okay, so that means when you say you're going to move up 1 unit, that means you're going to add 1 to each one of the y values. So it's kind of like a transitional period. So -2, -1, 0, 1, and 2. So 1/9 plus 1 would be +3 over +9 over 9, which would be 10 over 9 now. That's where my new y value is going to be. Okay, 1/3 plus 3 over 3 to get that plus 1 would be 4 over 3. Zero plus 1 would be at 2. 3 plus 1 would be at 4. And 9 plus 1 would be at 10. So there's my new values. But then you got this 1/2, which means I'm now going to take all those y values and multiply them by 1/2. Okay, so when I times them by 1/2, that's going to give me 10 over 18. So I have a point at -2, 10 over 18. Now 10 over 18 is like 0.555. So -2, about right there. And you're going to do your best to judge it. 4 over 3 times 1/2 is going to give you 4 over 6, which is just 2/3. Okay. 0, 2 times 1/2 is going to be still at 0, 1. Four times 1/2 would be at 1, 2. And 10 times 1/2 would be at 5. So there is your function transformation. So your asymptotes, I apologize, but I realized I made a mistake as I was working this problem out, so I'm going to have to redo it. Okay, because so I didn't make a mistake at this part. Your x, y should still be the same. So -2, -1, 0, 1, and 2, 1/9, 1/3, 1, 3, and 9. But what I did make as a mistake is you should do the multiplying by 1/2 first. I'm going to multiply each one of these by 1/2, which now gives me 1 over 18, 1 over 6, 1/2, 3/2, and 9/2. Then you should add 1 to each one of them. So now when I add 1, I'm adding 18 plus 18 over 18. Get 19 over 18. Plus 6 over 6, which gives me 7, 6. Plus 2 over 2. So now I'm at 3 over 2. Plus 2 over 2. So now I'm at 5 over 2. And then plus 2 over 2. And I know it's hard to read my writing in this. Would be 11 over 2. So 1.5 is going to be your new asymptote. As you go this way, you're at 5 over 2, 2.5. And 11 over 2, which would be 5.5. And then as you go this way, you're kind of creeping along. And what has happened now is your entire graph has shifted up 1 unit, which means your new asymptote is now here. That's your asymptote, y equals 1. Your y-intercept is at 0, 3 over 2. Okay. Your domain really hasn't changed. It's still going to be -infinity to infinity because the shape of the graph doesn't change. But your range will change because your asymptote has changed. It's now for everything's above 3 over 2. Because 3 over 2 to infinity is your range. And as I'm going this way, you're going to infinity. As you're getting this way, you're approaching the asymptote of 1. So that back number, that k value, is going to be your asymptote. And last one. All right, so same idea. Parent function is 3 over 2 to the x. Okay. So 3 over 2 would be 4 over 9, 2 over 3, 1, 3 over 2, and 9 over 4. Okay. But then you have two things going on. Your x is now shifted left 4 units. So now let's make that happen. So when you're, sorry, right 4 units. So now this is going to be at 2, 4 over 9. So you're adding 4 basically to each one of these numbers. So now you're going to be at 3, 4 over 2 over 3. You're going to be at 4, comma 1. You're going to be at 5, 3 over 2. Then you're going to be at 6, 9 over 4. So 4, negative 4 is my new point. And then the rest of them follow suit, and I'll show you what they are. You would have to add their exponents, but basically this would be at negative 3.5. And then 6 would be at like negative 2.75 roughly. And then these ones up here would be like negative 4.3, give or take. And slowly it goes like this. So actually it goes, I'll do that. It goes this way. Okay. And here's your new asymptote. And again, it's that k value. So our asymptote is y equals negative 5. All right. Okay. So your range is going to be everything above negative 5. So it's negative 5 to infinity. Again, I'm going this way. I'm going to infinity. As I go this way, I'm approaching that asymptote at negative 5. My y-intercept has changed. It's now at this value right here when x is 0. So you got to plug in 0 in there. So when x is 0, so let's figure it out. So it's 3 over 2 to the negative 4. So 3 to the 4th would be 81 over 2 to the 4th. $16. So it would be 16 over 81 minus 5, which would be 405. It's the common denominator. So 80 minus 405, negative 325 over 405. And then they're both divisible by 5 at least. That's negative 65 over 81. So negative 65 over 81 is my y-intercept. We want wants it in decimal, you can just get it in decimal. And the domain, again, they don't change really. It's going to be negative infinity to infinity.